Okay folks, in this lesson we take a look at the subsurface scattering section of the Arnold standard surface shader. So this is the material that we have applied to this dragon, and if I just take a look at the current scene that we have, as you can see we have this dragon model. Okay, I have also applied an Arnold parameter tag, and under the subdivision change the type to cat clock and increase the iteration to 1 so we get a smoother surface. And also we have these two lights. This is our main light, which is coming the right side, and we have this fill light, which is coming from the left side. Okay, so let me open up the standard surface shader, and after transmission, as you can see, we have the subsurface section. For now I'm just going to zero out the base weight. We can zero out the specular weight as well, but let's have some specular as we are explaining the subsurface section. Subsurface scattering basically simulates the effect of light entering an object and scattering beneath its surface. Not all light reflects from a surface. Some of it will penetrate below the surface of an illuminated object. There it will be absorbed by the material and scattered internally. Some of this scattered light will make its way back out of the surface and become visible to the camera. This is known as subsurface scattering, or SSS. SSS is necessary for the realistic rendering of materials such as marble, skin, leaves, wax, and milk. The SSS component in this shader is calculated using a brute force ray tracing method. Now, as you can see, by default, the subsurface scattering weight is set to 0 and all the other parameters are grayed out. And as soon as I start increasing the weight, if I actually, let me just take a look at the preview here, we can start to see the subsurface scattering effect comes to play. And now I can actually run the IPR. Actually, to see the pure subsurface scattering effect a bit better, let me zero out the weight for now. So as you can see here, weight is the amount of the subsurface scattering contribution, and the energy conserving principle is very important as well here. As you can see, if I change the base color right now to, let's say, a very obvious, this purple color maybe, and if I increase the base weight, let's say to something like 0.8, you can see the base component of the standard surface doesn't affect the material or the shader at all, because the subsurface scattering weight is set to 1. So in order to actually be able to see any effect from the base component, we need to decrease our subsurface scattering weight to start seeing the effect of the base color. Now, it's like when we discussed the transmission and the base color in our previous lesson. We mentioned that if the transmission weight is set to 1, the base weight won't affect the shader at all, and in order to see the base component affecting the shader, we needed to basically decrease the transmission weight and then increase the base weight. The same thing is happening here. When the subsurface scattering weight is set to 1, the base component is not going to affect the shader. And sometimes you actually need to have both your subsurface scattering and your base component to create a realistic subsurface scattering shader, for example, like skin. And in that case, you need to have a subsurface scattering weight less than 1. But in this case, let's continue with the rest of the parameters. Next, we have color, which is the color used to determine the subsurface scattering effect. So if I use another color here, you can immediately see the effect. For example, if I want to create something like skin, I need to use kind of a fleshy color, and then control the radius and the weight and the scale parameters. For something like, for example, potato, I would use a yellow color and stuff like that. Let me just set this to this white color. Then we have radius, which is the radius of the area each sample affects, and higher values will smooth the appearance of the subsurface scattering And increasing the value here can radically change the appearance of the material. If the radius value is too low, we can see a subsurface scattering effect like in leather, and if we increase the value, you can see a subsurface scattering, a more powerful subsurface scattering and smoother effect, like for example in marble. So you can see with the radius of 10, this is the result, this is the subsurface scattering that we are getting. And if I change the radius here to, let's say, something like 1, so as you can see right now, if I just take a snap and compare it to when the radius was 10 centimeter, you can see this is the render with radius set to 10 centimeter, and this is 1 centimeter. Obviously, as you can see in the first one, with the higher radius value, you get this very smooth marble-like render, and in this one, this subsurface scattering is mostly visible in these thinner parts that have a radius less than 1 centimeter, and it's less visible in the other parts. So when you increase the radius value, we allow the rays to scatter further beneath the object, and therefore seeing stronger SSS effect. Also, if I just close this, also you can have different radius amount for R and G and B channels. For example, if I just uncheck this uniform radius, I can increase the radius of my R channel, let's say to something like 3 centimeters. And now I'm letting the red channel to scatter deeper compared to the green and the blue channel. And this is very useful when you are trying to create the subsurface scattering or the shader for a skin, for example, surface. In this case, you obviously need the red rays to scatter deeper to create that realistic look. In this case, we can set the radius, let's say to something like maybe 1, maybe something like 0.35, and maybe something like 0.2. And now, as you can see, the red, green, and blue rays are scattered differently and allowed in different depths, and that's why we are getting this kind of skin-like effect. And shader, obviously, we need to adjust our subsurface color and our base color to get the very exact effect that we are after. Now, another thing I want to talk about is this. There are some presets that they have hidden it quite pretty well. I don't know why, but if you actually click on this triangle beside color, you can see you have some presets. I would suggest that these presets go probably before the weight parameter, so everybody can access, because it doesn't affect only the color value, it actually affects the radius parameter as well. So if I, let's say, you can see we have a preset for apple, we have a preset for chicken, we have ketchup, we have different presets that can be very useful. You see we have something like marble. In this case, we need to increase our specular reflections. And as you can see in the case of marble, the exact same is happening, because we need that kind of reddish, yellowish tint that marble demonstrates. You can see the red channel has scattered further beneath the surface compared to the green and the blue channels, and this is the effect we are getting. It's a very nice marble effect, as you can see. You can try, for example, skin. You can have this second skin preset. You can try this presets on your own. We have scale, which basically scales the amount of subsurface scattering and multiplies the SSS radius color. So it's an overall multiplier. If I just increase these from 1, let's say, to, let me just go to custom and use a 1 centimeter preset, or that marble preset was actually quite nice. So if I want to multiply the overall effect, I can use this scale factor. So this is with the scale set to 1. Let's just wait for the IPR to be finished. So this is with the scale set to 1. Let me just take a snap as well, and now increase the scale to something like 5 to see what we're going to get. So this is with the scale value set to 5, and this is with the scale value set to 1. So as you can see, it's an overall multiplier. It basically multiplies the overall effect and the effects of, for example, the radius, the color parameters, and you might say it's repetitive of the radius, but if you imagine, for example, in this case that we have different radius values for our G and B channels, we can multiply all of them at once with the scale value. So that's why this radius, this scale parameter, is here as well. Now let me set the scale back to 1. And another thing that we left out when we're discussing the sampling was the SSS samples. If I go to my render settings, I still haven't set it to Arnold, so let's set it to Arnold. We have these SSS samples under the main tab, which this value controls the number of lighting samples, both direct and indirect, that will be taken to estimate lighting within a radius of the point being shaded to compute subsurface scattering. And higher values obviously produce a cleaner subsurface scattering solution, but will take longer to render. So in this case, what I'm actually going to do is to go to my AOVs and search for the SSS direct, the whole SSS effect, the SSS direct, and the SSS indirect. Okay. And let's try to render with the SSS set to 2 and with the SSS set to 6. I'm just going to make sure, let's use a smaller dimensions like 800 by 450. The render settings for the SSS is set to 2 at the time being. Let me just go to the picture viewer and clean these renders. Let's take a render with the SSS sample set to 2 and see what we're going to get. So here is our render, and if I take a look, obviously it's very noisy, and if I go to the layer tab and take a look at the SSS direct and SSS indirect passes, you can see they are very noisy. Now let's increase our subsurface scattering samples to something like 6 and try another render. Let me just rename this to SSS2 and this is SSS6. So let's see what we're going to get. Now in the second render, which took significantly longer compared to our previous render, you can see we have this quite clean render. Let me just, is SSS sample set to 2 and this is set to 6. And if I take a look at the SSS indirect and SSS direct passes, you can see it's a lot cleaner. And this is our whole SSS effect with when set to 2 and when set to 6. It's obviously a lot cleaner, but it's gonna take longer to render. Okay, so that's about the subsurface scattering section of the Arnold standard surface shader. And now we can take a look at this code section in our next lesson. So see you there.